Good afternoon, awesome Rainbow people. It's a pleasure and honor to be on the stage. Thank you for joining us, especially that the competition around the rooms is very fierce. Let's do the quick introduction on our end. I'm joined on the stage with Daniel.
Hi, I'm Daniel. I am AWS community builder and one of the early adopters of Amazon verified permission and CEDAR.
And my name is Wojciech, short one is Wojtek. I'm working at AWS as a developer advocate. We both are based in Poland. That's how we met. Because Daniel has said he's one of the most active AWS community members that are actually working with verified permissions, CEDAR, and authorization, which is today's topic. If you are from CE, Central and Eastern Europe, don't be shy. Come after the talk. We will be happy to grab a selfie, talk about the permission security and all the stuff. This session will be handled in the form of a dialogue. So I will be this bad product owner that will give you the requirements, and Daniel will be savior. He will implement everything and show how easy it would be to actually build it in the 40 minutes.
I hope.
So before we will start, we need to do the clarification, the obvious one, especially if we are talking about authorization. Probably most of you know this, but authentication and authorization, those are two different things. They are very important and related. And in terms of the definitions, authentication is defining who the user is and verifying who the user is. We are talking about the identity. On the other hand, authorization is about what user or that particular persona already authenticated is allowed to do. And today's talk will be about authorization. So AuthZ in short, but we need to talk about those two topics because they are important and related. Our main assumption today will be that the presented example will have authentication already handled. So we will have a service that will provide authentication, but everything else that we will develop will be built on top of the services that will enable us to create authorization. And we would like to start with the first poll. If you haven't done that so far, please scan the QR code, and there is a first question waiting for you. The question is, how complex is your current authorization in your app? And we are asking this question because this is very important to actually establish the baseline. We would like to know how complicated scenarios are you handling. We will have multiple examples throughout the talk that will cover multiple different cases, but it will be good to hear and see how much and how different they are. And we already see the first results. And I'm actually very glad that there is a majority of role-based access control because we had this example covered, but we also have ABAC, so attribute-based access control, and we also will show a few more different examples throughout the talk. So thank you for the results. And we are talking about authorization because permissions are important. Every single application needs those permissions. So there are admins, there are other roles in the application. Every single time that you are having those users that are accessing data or accessing the application on your behalf, they have some certain rules that they need to adhere to. And permissions are actually the way of handling the whole thing. But those permissions are tricky because everything starts with a very pristine, clean code. But eventually, when you are trying to add those permissions to the code, it turns out that this red, ugly, complicated mess doesn't appear overnight, obviously, but at the same time, it actually bloats your code and introduces additional complexity. It makes it harder to maintain, harder to understand, hard to read. And essentially, in the long term, you are facing those issues when you are returning to that code and you are wondering what was the purpose. And because of that, this thing is less maintainable, it would be great to tackle this in a different, better way. But this is just part of the problem. Another problem is that when every single time you are actually developing those permissions and authorization engines, you are creating some kind of content management UI that will customly handle those roles, the groups, permissions, and managing this. Then you need to handle everything on the backend side for the back office of the implementation. And this actually builds additional complexity aside of your application that you need to maintain and develop. And this is another way of actually introducing accidental complexity to your problem. You should focus rather on essential complexity to solving the business problem, giving value to the business, instead of actually handling those accidental elements. We already saw on the slide with the results that majority of you actually handles role-based access control, but there are other ways of handling authorization models. We already talked about attribute-based access control, which is a little bit more different than the role-based, which is hierarchical, introduces groups or roles, depending on the name. Attribute-based access control is actually something much more flexible, but at the same time, it's a bit different in terms of how we can handle this. We are actually applying certain attributes, and based on that attributes, we will make those authorization decisions. And then there is a landscape of multiple different approaches. So we have other mixed approaches, we have simpler ones, we have something different like claims-based access control or context-based access control, and we will try to cover majority of those examples throughout the talk. Here's the second question that we would like to ask. Again, if you can scan the QR code, we'll be very grateful. How do you currently handle authorization in your applications? Is it a custom thing? Are you using something different? It would be great to see all those results as well. And this is important for us because we will be talking about something that is called a policy-based authorization, which is a very specific model, but at the same time, it is very flexible and allows you to handle it in a very graceful way. Okay, I see that majority of you are using custom-built solution. There are some people using open source libraries. We have a lot using cloud providers, IAM. And speaking about IAM, which we will cover in a moment, this is one of the cases that we've seen that it's happening for the customers. But at the same time, AWS Identity and Access Management wasn't developed to actually solve this case. So in many cases, it may not be the best possible solution to solve it. But analogy with IAM is actually very good because we are talking about policy-based authorization. If you think about AWS Identity and Access Management, the evaluation engine that is behind and evaluating those policies, it's exactly the thing that we will be showing today, but built on top of something different and different service. And when you are writing those IAM policies, you are writing them in JSON and then uploading to the verification for the authorization engine. So this analogy between those two worlds is actually very, very good. However, as I told you, AWS IAM wasn't developed in mind to actually handle custom application logic, custom application permissions, and everything else. So it's not the best solution for handling your authorization inside your applications. It would be great to have something that will be handling this in a way of authorization as a service. So something that will be used as a fully managed service when you can offload all the complexity and rely on the provided side. And this is very important to actually have it as a fully managed service because it will save your time and reduce the complexity. And eventually you will be able to benefit from the work that is done by someone else and focus on the most important stuff inside your application. And that's why AWS released Amazon Verified Permissions. How many of you heard about this? Raise your hand, please. Majority, that's great. So this is actually one of the most important services that we will cover today in terms of authorization. And this is the key piece that allows you to plug in the authorization engine into your applications. It was built in a purpose to actually handle custom designed solutions like your applications, but at the same time to offload everything into a fully managed service. So it works as the kind of a policy store that you are defining all the permissions in the form of the policies. You are doing the administration either through the management console or API or infrastructure as code. And then you can test it throughout the AWS management console as well. On the other end, you are writing your application, and then you are calling a specific APIs that are oriented on or variants of something that we call isAuthorize. Literally, we have isAuthorize API that actually does the authorization evaluation based on the policies and returns information, deny or allow. Obviously, your application can also manage those permissions and policies for you. And the bottom line is that we need to plug in the authorization into your application as seamlessly as possible. So as I told you, this is also a policy store. This is authorization engine. It also allows you to audit all those fine-grained policies. And last but not least, it allows you to plug in everything in your custom application. But how do you write those permissions? So essentially, as we talked, we are talking about policy-based authorization. So you are writing those policies in a specific language. It's called CDAR. And in that language, you are defining those policies, creates and stores them inside the Amazon verified permissions. And as a result, you will get an API about which you can use to verify the authorization decisions. Having a separate language gives you the benefit of actually having something expressive and very readable. So you will be able to actually manage that. And CDAR is an open source ecosystem, which is also a CDAR policy language, but also evaluation engine that allows you to write those policies and then leverage the results in the form of the easy to analyze policies and also the evaluation results. As I told you, it is an open source set of tools. And this is also written in Rust, so we can actually peek under the hood and see how good the performance is. And team behind CDAR actually said that they chose Rust to actually give the performance to actually evaluation and those authorization rules. In terms of how those CDAR policies are created, we have two different blocks, ahead and condition. Condition is optional. And then inside those two different sections, we have 4 different elements. We have principal, action, resource, and optional context. Principal is who is doing who is evaluated against this permission. Action is what kind of actions will be evaluated, and resource to what kind of resources we are evaluating. Then in the context, you can provide a contextual information about either a particular request or something that is very specific to actual call regarding the authorization. Outside of the policies, we have also a schema that defines the whole structure, and all of those actions, those principles, resources, all of that is described in the schema. The purpose of the schema is to actually handle the data model and semantics that will be helped in terms of validation. So you will be able to validate the entities and relations between them. You will be able to validate if those policies are actually referring to the proper attributes and proper values in those attributes. So in this way, you will be able to check and make sure that your policies and your authorization rules are correct. And schema is handled and stored inside Amazon verified permissions as well. Every single time that you are doing a request, you are providing CDAR policies, you are having the application entity data, you are providing context, schema is stored inside the verified permissions, and then all of those elements are bridged together, and then you are going through the evaluation phase. As a result of the evaluation, you will see that either this particular action is allowed, denied, or there will be an error if there is a malformed policy or the request is malformed. And speaking about the performance, as I told you, CDAR is written in Rust, and Amazon Verified Permissions uses CDAR underneath. And that's why those typical requests, even handling hundreds of policies and thousands of entities, are evaluated under a single millisecond. So CDAR provides you the policy language, provides you the ability to define the schema, and also evaluation engine. But that's not everything. There is also something related to the policy administration. And here is the Amazon Verified Permissions unique value proposition, because this is a managed service that also provides you the test bench, ability to store those policies, very performant API and scalable API, and ability to delegate the administrative purposes throughout the console. So enough introduction. Let's introduce the actual use case. It will be a very simple bookstore app. And you can see on the slide that the diagram is not very complicated, but we will actually cover a lot of different use cases in terms of authorization. One thing that is very important to mention here is that authentication layer and user storage layer is handled externally in Amazon Cognito. So it means that we have those users defined in Amazon Cognito, but they are not stored or handled anywhere inside the Amazon Verified Permissions. Those are two different stores. In Amazon Verified Permissions, we will have rules that will refer to those users, but at the same time, the actual user profile is stored somewhere else. The rest of the application should be very straightforward to analyze. We have a very simple front-end application that does the authenticated API calls to the REST API. That REST API triggers an AWS Lambda, and Lambda actually asks verified permissions policy store for the is it allowed or denied in terms of the particular request. In terms of how many resources and different resources do we have, there are 3 different CloudFormation stacks in that example. We have the authentication which covers the Amazon Cognito case. We have the stack with authorization. This is the policy store and all the policies that we have in the application. And we will gradually create those policies together. And then last but not least, we have a very simple serverless application that I've shown you. Lambda functions, REST API, and connected Cognito authorizer. All of those elements are actually referred between each other with parameter store, AWS Systems Manager parameter store, so you are able to actually populate proper identifiers throughout the application code. This is important from the perspective of policy store ID, because this needs to be referred when we will do the API calls to the service. Last but not least, we have this simple UI. In the simple UI, you can create any users you would like to. We have 2 additional custom attributes per user. One is role, and another one is years as member. Those 2 attributes will be important for us to actually implement those use cases. And the sign-up process is 2 steps. First one is actually doing the regular sign-up. Then we will receive a confirmation code through the email. After signing up and receiving that confirmation code, we can sign in as this user. And as a result, we will see a list of books in our application. And depending on which kind of permissions and attributes given user will have, you will see a different set of books. As you can see, we have premium offers, we have regular offers. That's everything what we have. In terms of Cognito and place where we store users, we will have 7 users in total that are spread across 3 different roles. So there will be admins, customers, and publishers. And this way, we will also show you 3 different examples how we can handle the authorization rules. And as I told you, those users have 2 small additional custom attributes, which is role and also years as member. In terms of Lambda functions, we have 2 different Lambda functions. One is for showing the details of the book, and one is for listing the books. We will modify the listing books Lambda, and we will show you how much code will be needed to add in order to support Amazon Verified Permissions. It won't be a lot, but there will be some things to explain throughout the implementation. And last but not least, as I told you, all the configuration that we have is provided through the environment variables based on those parameter store attributes that I showed you earlier. And last but not least, we also have an API. API is done throughout the API gateway, and API is also authenticated. So we use the same Cognito user pool, and this Cognito authorizer is also enabled inside those API endpoints. And this way, we are actually sharing the same token that will be used for authenticating the users. And then after authenticating, we will be able to extract some information in the code from that token to check particular attributes values and then send them to the authorization engine. And in terms of authorization engine, the main central piece for Amazon Verified Permissions is policy store. So we created this policy store already, and inside this policy store we have schema and we have policies. Schema defines those entities like user, role, and book, and actions, how many actions we have. And additionally, we are defining the attributes of every single available entity. Schema is also responsible for showing relationship between different entities, like in this case, user is member of role, and also book has owner that is user. So it's time to switch hats. Now I will become the product owner, and Daniel will be our savior. And the first requirement that I prepared for Daniel is actually to have administrator and everybody else. This will be very basic role-based access control. I'm doing air quotes because this is essentially not a full airbag, but at the same time, it will give you an overview how much work it will require to enable Amazon Verified Permissions in your apps. Then we will go through the proper airbag later on. We need to start with the baseline, and the repository that we will share with you is prepared in a way that on a separate branch, you have all the steps throughout we will go today. On the step number 0, the starting point, we have no authorization. So policy store that we created for you is empty. There is no schema, there are no policies, so everything waits for creation. And then we have very brief implementation inside AWS Lambda that essentially does not do any authorization call. So we load our static items from a database.json, that is our mock database. Then we instantiate the client for verified permissions via BOA209, and in the end, we do no authorization decision. So it means that we return all the books for all users at the same time. This will be our baseline. In terms of users, as I told you, we have 7 different users. There are 2 admins, Tom and Frank. There are 3 customers, Andrew, Susan, and Toby, and they will handle each of them very different authorization rule that we would like to show. And we have also 2 publishers, William and Dante, who will actually have a very different authorization rules implemented later on. And if you are bad with names, like me, don't worry, we will explain you every single time who is who when we will show the examples. So at the moment, all users see everything. So if I will log as admin, I will see exactly the same books as Toby, which is user, or customer rather, and Dante, who is a publisher. So all 3 different roles will see exactly the same result. Now it's time to code, and now it's time to build it with Daniel.
Finally, my turn. So, coding time. Let's see what the change for requirement one looks like. So, as a foundation, we still have an empty policy store. So what we need to do now is add schema. Schema in the JSON format consists of items like actions, resources, principle, attributes, and relationship, and also the basic policy for role-based access control. We'll see it in the moment, and at the end we also need to make some adjustment to the Lambda function, but let's review it within the minute. So let's start from the schema. We have 3 entities, user, role, and book, and also we have 2 relationships. The first relationship is between user and role. User is a member of a role, and the second relationship is between book and user. Book has an owner that is a user entity. In here you can see the JSON of that, but you can also in AVP see the visual weight within the visual mode. And now we have one policy. This policy allowed that any user that has roles as admin can view our resources, which in fact are books. Now let's review the Lambda code. So first of all, we have Lambda handler, which has an authorization decision, and this decision consists of 3 main items. The first one is prepare an authorization request. Call is authorize API operation from the AWS SDK, and also determine the response based on the authorization response. And let's check how to construct the request to Amazon verified permission first. What we need to do to provide the entities, so identifiers like user, so the principal, also the resource, its relationship. We can also see roles. So we fetching from the user info the information about the user role. And also we need to construct the information of the specific request. So like which principal, resource, and which action will be evaluated. At the end, we need to determine based on the response from AVP whether we allow or deny the access. This information will be from the response, and at the end, we either return empty list for if the response will be denied, so there is no books, or if it's allowed, we just return all books for admins. Now let's check it in practice. We have two admins, Tom and we can see all of the books. And now let's check Frank.
So far, so good.
No surprise. And now let's check another customer like Toby or Dante.
And Dante is publisher.
Exactly, and Toby is customer, so we cannot see anything. So far, so good.
You are on fire. That's great. That looks good.
Let's see how long.
Exactly. So let's see how long. So I would like to introduce a more advanced use case, still role-based access control, but let's time do it properly. Like I would like to allow all the customers to also list the books. Let's leave publishers to not see anything. And also, I would like to deny access for a specific user. In this particular case, I would like to disable access for one of the admins. Let's call it Frank.
Let's see what we can do. So, coding time. So, what we need to do is to forbid the specific user and also give access to all customers to see some data. So finally, we'll do some proper role-based access control. Let's start. So the second requirement is not much work to do. Airbag is almost there. So what we need to do is just to define proper policies because we already make the evaluation within the Lambda function. We have policy store, we have schema, all good. So let's start. We just created two new policies, one for allowing the specific type of user, which is customer, to see all books, and the second, which is the static one as well, which explicitly deny the specific user. What does it mean? That even admin belongs to the specific group which allows to see data. In here, the explicit deny is conducted, so due to that reason, the user will be forbidden to access it. So let's check the policies. We have two new policies, and let's check it. So the first is about allowing access for group of role which has customer. Easy as that. And also previously we have it the same for admin. So just matter of changing the role name. And the last one, we explicitly forbid. Please take a look at this forbid effect, that the principal Frank will be forbidden to access view action on any resources. And let's check it in practice. So first Tom, he's an admin. Let's see whether it's working seamlessly. And it is indeed. Now let's check Frank.
Okay, one of two is done.
Now let's check Toby, his customer.
So Toby haven't seen anything. Now it should see all the books.
Exactly.
Correct.
So everything working as expected. And now Dante. Dante is publisher. So he's not affected at all. He still cannot see anything.
Okay, that's That's time for requirement number 3. So let's not stop here and do another but different requirement, not role-based access control, but context-specific one. Let's assume that our users are accessing the bookstore from different parts of the world, and I would like to disallow accessing those who are outside the US. So every single time that someone is outside of the US, they shouldn't see anything. How would you handle that?
Started to be more tricky, but let's see what we can do, boss. So let's implement the change. So what we will be doing here is context-based access control because it's a region-specific, and usually such as thing we can do it by geolocalization. So based on the IP address, we're fetching it from the request or from the API gateway, and we can check from which region the user it is. So we need to pass the context to the schema. So context is always related to the action. So to the view, we need to add context based on region. Also, we need to add a new policy for that, and also very, very small adjustment to Lambda function. Let's start from schema. So all entities will be the same for actions, but to the action in this JSON, you can see that we added a new attribute called region. It's a string, and it's a required one because we would like to check each and every user in our system. So it's just a matter of adding this context to the view action. And now let's check the policies. We can see one extra policy. The last one. So what we can see that for any principal and any resource for the view action, we checking the region. Whether it's outside the US, the access will be declined because it's still the 4-bit effect, and we're checking the context. And now let's check the Lambda function. So in terms of the code adjustment, just one small change when we're constructing the authorization request. We just need to fetch the region from the user information and then just pass it to the context map object. And it will be incorporated into the authorization request. And that's it.
So in our use case, the only entity, the only user entity outside of US is Toby. So only Toby shouldn't see anything, right? Let's check it.
In theory, yes. In practice, we'll find out. So let's check Andrew first.
Andrew is a customer, should see everything.
He's located in US. All good. So far, so good. Now,
Susan.
Susan.
Also customer, also in US, right?
Yes. And now let's check Toby. And the moment of truth. Yay.
That's great. I think you deserve an applause. But that's not everything. We have fourth and fifth requirement. Fourth one will be introducing attribute-based access control. And I'm telling about ABAC, but I would like to achieve something business-wise. Let's reward loyal customers. So I would like to give a permission to list premium offers only to the customers that are at least 2 years with our bookstore. How you can handle that?
Finally, some attribute-based access control. Yeah, challenge. Everything is challenging nowadays. So let's check how we can do it. So this time, Susan will be affected because she's below 2 years within our bookstore application. And let's focus on the implementation details. So attributes-based access control. So we need to make a little bit of work. So first of all, we need to add new action, view with premium offers, because we somehow need to distinguish it. It will be for the customer within our bookstore. And also we'll need one attribute for our principals, which is years as member. And this one will be optional because it will be only for customers. We don't need it for admin or publishers. We also need to add 2 new policies to our system to forbid and allow based on this years as member values. And in the end, small, not small modification to the Lambda function, but we'll review it in a sec. So schema, we can see new action view with premium offers. We can see that it applies to the same principle and resources. And now also the JSON, we can see that also a new attribute was added. Optional. And now let's check 2 new policies. So we allowing and forbidding. So first one, still we checking role customer. The action is view with premium offers, and also we checking whether the years are member is present, and if then we checking whether it's smaller or greater than equal to based on our requirements. Easy as that. And now the Lambda function. So first, we define a change to descriptions. So we need to be aware of this description, and also we'll need to change the way we construct authorization request. What does it mean? We need to populate years and members because it will be very important to pass it as well. So in here, we only checking it for the customer. So first we need to check whether the user role is customer, and then populate this value. We're fetching it from the user info information. And then whether we determine product list, we also need to check it. So first, based on the decision, so first checking the role, and then the policy description. And based on that, we either return all books including premium offers, or just books without the premium offers. And you may ask, like, why there is need for second policy? Because in policy store, everything is denied by default. So why we forbidding it? So first of all, it's because it's a new action, and because of the previous policies that have to be supported as well. Maybe now time for the demo. So before, as Wojtek told you, the policy affects only 1 out of 3 customers. So again, Toby's access is forbidden based on the other policy, so the context-based access control. Toby is outside US. Now Susan. Susan is 1 year with bookstore, so she will be only regular. She can only list regular books. And the last one, Andrew, is our lawyer customer. So he will list all books, including those premium offers. Let's check it in practice. So first, Andrew.
So far, so good.
We can see all offers also with this orange annotation. Now Toby.
That's great. You didn't break anything.
Oof, what a relief. And now Susan. So Susan lost access to the books annotated with premium orange marker. So far so good.
Requirement number 4 resolved. Thank you so much.
I hope that's it.
No, there's another one. This one will be tricky because we would like to do something for the publishers with a very granular access to the resources. So I would like to introduce ability to list books that are owned by the publishers. So every single publisher should only see books that they own. And additionally, I would like to be able to add a one particular book that be accessible for a given publisher. So I would like to define a policy which will say, this publisher will see this book.
Sounds like ownership, role-based access control, and also explicitly allow for a specific resource. Yep, coding time. So first of all, nice requirement, pretty tricky, but quite easy to implement it with ABP. So in terms of policies, it's relatively simple because we just need to add 2 new policies. We don't need to modify schema at all. So first, policy will be about publisher that can see books he or she owns, and also individual policy, static one, that we explicitly grant access to the specific resource for a specific principle. And the change in the code will require much more work, but first thing first. So schema, nothing changed in schema definition, but now let's check the policies. We can see 2 extra ones. So first one is about allows publisher to see books they own. So we can see finally our role publisher, view, and finally in when clause we can see principal equal resource owner. And the second one, we explicitly permit Dante to see the book with the UID. Like, why are we doing UID? Why we cannot just hardcode the name? Books can change their name, could be similar books or with the same name. With UID, which is unique identifier, is much easier to create a static policy, and we don't need to change it if anything will change. But you can ask, but you hard-coded Dante.
So it's a trade-off, how frequently certain things will change.
Exactly. So it's always about the trade-off, but the recommendation is always to use unique identifier to avoid changing policies. Let's continue. So now the code. So for publisher, we'll use something differently. Batch is authorizer operations. It means that we can run multiple requests in a single operation, so by using batches. Why we would like to do it? Because it will be just one request. It's either resource specific or principal specific when we have common entities. And what is the benefit? Will improve the performance and also decrease cost because we just pay for one request. In case of the change, so first of all, we need to change the way we constructing the payload. So we adding new function construct batch authorized request. What we have here will be that first we need to fetch our entities. So we need to fetch books from William and also from Dante to pass it as a common list of entities. And also we need to create the array of requests. So check a couple of books for William and for Dante and send it over to ABP. That's the main change. And also in the case of, we can here see the identifiers for the books. So book ID, username. And in case of determine product list, so as a response from the ABP, we'll obtain the array of authorization decisions. So we just need to map over them and check and conduct our logic that we can return the proper books. And also at the beginning of the function, we'll define our policy description. So based on them, we can filter books properly.
So why do I using those UIDs? Because that could be something that looks very tricky.
So we can see our database JSON is a file with our identifiers. So we need to have authorization mechanisms that require different handling. So first is fetches all records. We extracting those necessary ones for making the authorization decision to construct the proper payload. Then we send it to ABP. We obtain the authorization response, and based on that, we can filter them out properly. And that's it.
So let's test it.
Yes. So now let's check first William. He's publisher, and he should only see one book that he owns. And here you are.
So far, so good.
And now let's check Dante. Dante, on the other hand, owns one book, but we also add the possibility that he has access to the specific book that one William owns, and we can see two books over here.
So it worked. Congrats. Yay. Thank you so much for implementing everything. All right, okay, so it's time to wrap up. It was a ton of new information, so we would like to wrap up everything for you. First things first, we recommend you to look the documentation that is provided by the CDAR team. There are a lot of useful informations, including best practices and recommendations. One of the best practices, actually, Daniel told you about using unique identifiers, and this is a very important, one of those very important that is listed there as well. So this is the first place to look. And in terms of the next of the summary, I would like to ask you for another question. What would be the most important factor when choosing an authorization solution? Because many of you actually have the custom-based solutions, but it would be great to see what would be the ability to actually determine how to choose an authorization solution provider. And I'm asking about this because we do have considerations that are important. So some of you will choose security and compliance, majority actually, ease of use and integration, flexibility, pricing and cost efficiency. I'm actually surprised that there's so little people interested in pricing, but Daniel has a very interesting story about the pricing as well. So let's move back to the considerations. So in terms of lock-in, I actually split this in three different elements: lock-in, auditability, and pricing. In terms of lock-in, I would like to discuss the ability to leverage CDAR as the common platform and postpone the decision about either using Amazon Verified Permissions or hosting your own solution based on CDAR. Because if you will use Amazon Verified Permissions within the CDAR policies, later on, if you will decide that from whatever reason you would like to self-host, you should be able to do it as well. There will be no change in that regard, especially that CDAR is available as an open source solution. Another consideration is auditability, and this is one of the things that actually is brought to the table thanks to the Amazon Verified Permissions. Because Amazon Verified Permissions integrates seamlessly with AWS CloudTrail. So by default, even without defining any additional trails, just by enabling AWS CloudTrail in your account, you will see all the API calls that are modifying policy store and asking about the policy store. So without anything, you will already see those inside your AWS CloudTrail logs. Then you can define the custom trails, filter based on the source of that trail, and monitor all the changes that are happening in terms of management of your policies within the Amazon Verified Permissions. But that's not everything. You can also monitor all those actions that are happening in your application, like is authorized, batch is authorized, and other related. And you can do it by creating a data events trail inside CloudTrail. So here is an example trail that was created for the CloudTrail. And as a result, you will see that it actually captures all the data events from Amazon Verified Permissions. And those events will be stored on Amazon S3 as in any other trail that you will enable in CloudTrail. You can also see those events as objects on S3. And if you would like to see the content of those events, you can either extract it from those files, or you can enable CloudWatch logs. And thanks to that, I can show you what kind of information do we have inside those events. And we have literally everything, including who called that, with what parameters, what was the context, what was the whole authorization request, and also we have the information about the authorization decision. Was it allowed? Was it denied? What kind of entities we provide? So everything is there and available for audit. And last but not least, there is also pricing consideration. And here I would like to pass mic to Daniel because he has also very important thing.
Okay, so as you know, Amazon Verified Permission is a managed service. What does it mean? You just pay for a usage. So there is two items which you need to take into the consideration when dealing with pricing of AVP. First of all is management costs, so all operation regarding policy management. So creating policy, updating policy, creating policy store, putting schema, and so on. Those costs are very minimal because you don't often will change those policy. And the second cost is authorization cost. So this is authorized API calls as well as batches authorized. If you would like to decrease some costs, you can easily use batches authorized and just use one request which consists of batched request within the single request. And what is the other option? Can I use something else, like maybe just Cedar standalone because ABP maybe is too costly for me? So when you're dealing about comparing those two options like ABP or custom build alternative on top of the open source version, because Cedar is open source, as you already know, so you need to take into the consideration of TCO, which stands for total cost of ownership. So we have two options. One is fully managed service, Amazon Verified Permissions. So let's think what benefits we have. So in case of the complexity of implementing that, it's quite easy. It's working, it's managed service, you have already the SDK, you have all those nice features, test bench, policy store, which is the container for the policies, and InfoSec will approve it immediately. You can start fast. If we would like to estimate within the enterprise organization, the MVP will take like a couple of months, 3, maybe 5, depends. So what will be the ongoing monthly cost? So authorization request to AVP, obviously, and also cost of running Lambda function or ECS to run those logic. And what is the opportunity cost? Like, we can also extend our flow to, for example, implement caching to improve performance or downgrade costs. So we can use DynamoDB, we can use Redis, so Elasticache cluster to do it. It's all possible. But it's also the question whether you can implement it, cache, whether InfoSec will approve it. It depends, as always. And now, what is the alternative? So what we can do is use self-hosted Cedar, so this authorization engine. So we can define those policies in Cedar and run it on our own. So remember, Cedar is written in Rust. That's perfect because it's performant, but when you need to use it, so either you need to have team who can use Rust or they will learn it, or you can use some bindings or API for that, but it's obviously increased the complexity. And this complexity, on the other hand, in AVP is provided out of the box. You don't need to learn Rust at all. You just use AVP and that's it. So in case of build time, so our estimation was for MVP 9 months. But remember that you don't have those nice features like test bench, policy store, those visualization of schema, or even the console to play around it. So always remember about it. And what will be the ongoing monthly cost? This time you don't pay for the authorization request. You just pay for processing Lambda or ECS to run your Cedar stuff. And some opportunity costs. You just need to pay for your team that it will incorporate all those new functionalities which are missing from the AVP. You need to have DevOps to maintain your machines, stuff like that. Lack of auditability, security, whether InfoSec will approve it? I don't think so. So, conclusion, like in our case, return of investments from custom implementation on top of the self-hosted CDAR will happen after 4 years, assuming internal development. And whether it's acceptable, it all depends. In my case, we just selected AVP and we can start fast. And what I would like to show you at the end is the fact that CDAR is very flexible because you can use it within the AVP. And if you started to think AVP is too costly or not sufficient anymore for you, you can just grab your policy and run it standalone. There is not really lock-in in case of the CDAR policies.
That's correct. Thank you. So the final question for you, what would be the biggest obstacle based on what we presented in terms of using the Amazon verified permissions? If you can scan the QR code, we'll be grateful. And this is important because we are going to the final phase to provide you a little bit more resources, because I can imagine that those resources would be valuable if you would like to pursue and proceed with the implementation. And in the meantime, when we are waiting for results of the survey, I would like to show you the grant scheme for the zero trust of Amazon verified permissions. But I see that majority of you say that it's complications associated with migrating from an existing solution. And I can imagine that this would be a headache sometimes, but at the same time, it would pay off in the long term, as Daniel said. There is a lot of benefits of actually having a fully managed service instead of having a custom-built solution. Unfortunately, in terms of the solution that was built in the first place, that essentially that the first steps needs to be done and there will be a required learning curve for sure. In terms of a grander scheme, how Amazon verified permissions is established inside the AWS, it fits the whole purpose about zero trust, because it allows you to introduce the zero trust for your own applications. So this is one of the things that it could be very important from your end. In terms of the resources, here's the repository with all the code that we've shown you today. You can scan the QR code and access it later on. Daniel is also an author of a very nice CLI tool that allows you to learn around the Amazon verified permissions and CDAR. It supports all the actions, provides you the blueprints, and allows you to see how you could enable the Amazon verified permissions in your applications. If you are a more hands-on experienced person, there is a very good workshop created by the service team, which we can highly recommend. Daniel did it a few times. I did it myself. It's a very cheap one and also allows you to put your hands on in a very active way on the Amazon verified permissions. And last but not least, if you are interested in more resources about AVP and CDAR, check out the blog post that Daniel prepared, check the GitHub organization for CDAR, and contribute in any way you would like to, either to the roadmap, writing the bindings for your own language. Check other AWS reInvent 2023 sessions about Amazon verified permissions. There are a few already in the catalog. And last but not least, if you are a computer science nerd and you are like white papers, there is an amazing article on Amazon Science blog, how CDAR was built to actually ensure correctness with support of the automated reasoning and differential testing. This is a very interesting thing to read. Last but not least, stay connected with AWS, with AWS developers channels, with AWS Skills Builder, and community.aws when we publish the articles as well. This is everything what we prepared for you today. Thank you so much. Hopefully it was enjoyable.